All right, great presentation from David. Next, our last presentation on the purple track is Grahame Grieve, Principal of Health Intersections, and I'm happy to have him live. Hi, Grahame, how are you? I'm a big fan, by the way. Alyssa talks so much about you. All good things, though. I wanna leave it to you. It's your open floor to bring up your slides and start your presentation. Oh, I think you might be on mute.
You're right, I was on mute. No, I am not. Hello. And you see my slides? Great. Okay, so I need to talk about securing FHIR APIs in healthcare. So a FHIR API is a standard for APIs in healthcare. So FHIR is a formal standard that describes everybody's API. So it's rather than a single server API, it's a specification for APIs. So I'm going to tell you why I started working on FHIR first, and then we'll get into the details of FHIR and then the details of security. So we started working on FHIR because healthcare has broken processes. If you have experienced healthcare as either a receiver of it or a provider of it, you know that. Other industries are being transformed or were being transformed, and IT enables that. That was a process that wasn't really happening in healthcare. So this is written 10 years ago, this slide. This is when we started working on it. And it was, for us, one of the problems was it wasn't the right standard. But healthcare, everything is broken. And so fixing the standard is a long way short of fixing the problem. That's just really the case. So we knew that there's lots of other reasons there's problems in healthcare, but we wanted to work on an API specification. So then we created FHIR. It's really the web for healthcare. And for me, it's two parts. An open community that makes it easier to exchange healthcare information. That's our goal as a community. And it's open community, so open participation. Anybody can participate. You don't have to be a member of anything. Although most of our participants are full-time healthcare employees of healthcare, IT vendors, or institutions. And we meet around social media. And it's led by an organization called HL7, Health Level 7, which is a very old, obscure reference to an old OSI network model that nobody uses anymore. But Level 7 is really application level interchange. And so it's Health Level 7, Health Application Interchange. And so we describe how to exchange. So the community meets, argues about how to solve identified use cases, and then we write our argument into a specification, which we publish that describes how to exchange healthcare information. What's healthcare information? And that's a really hard question for us to answer, because the actual fact is anything is healthcare information if it becomes relevant. And so it's pretty hard for us to scope limit what we're doing. For instance, we've been asked to take banking on because healthcare does banking. We've managed to resist that. And we've been asked to take on user management, and we've resisted that. But it's an ongoing challenge. What's not healthcare information? Our public domain, Creative Commons, is the name and license. Web API where possible, but not all exchanges are web-based, and so we're interested in more than just web APIs. But for today, I'm focusing on particularly on the RESTful API part. And a big part of what we do is continuity with existing healthcare standards, and some of those are pretty horrifying because they go back. Well, some of the existing healthcare standards, IT standards, go back to long before we had IT. So, the turn of the 19th century, when people started thinking about coding information. And so that continuity sometimes is a bit of a challenge, but it's really important for the healthcare industry that we can bring forward our records from the past. I was visiting one institution. They had a fire in the 1950s, and they're still upset about having that fire in the 1950s. Now, the scope of healthcare is pretty broad, because we cover administrative information around who's in the hospital, where's the patient today, who's providing their care, which bed are they in, diagnostic information from labs and radio imaging services, and that covers user-generated data as well, which is wearables, monitoring, glucose monitor devices, those kind of things, information about clinical status, problem lists, medication management, and then care planning. Why are we doing what we're doing with the patient? What was their decision-making process? And that's kind of where the state of the art is. The billing and payment, because everybody cares about being paid for the healthcare they're providing. And we don't do the actual payment part, but why, and linking the payments to the care. And then we've got a whole project focusing on clinical knowledge representation, a formal representation of the bioscience and knowledge underlying the clinical process. And then we're looking at, how to characterize the performance of practitioners and institutions, and then clinical research around patient management. And finally, we've got a part we're working with, consent and the control of the distribution of information. This is kind of the base scope of the stuff that we describe. And then the way it works is we describe how you could do an API, but all systems vary. We can't force systems to align in all sorts of ways across different countries, across different institutions, across different choices they've made about which pieces of data they care about. And so there's a sort of a secondary process of saying, how do we adapt the standard API to our system? So all the APIs differ a little bit, and we can't stop them from doing that, but they do have this underlying continuity that reduces the cost of adapting from system to system. And we've got all sorts of systems built using FHIR now, and thousands coming. I just long ago lost track of coming, but patient access to data through patient hospital portals. That's a big part of the what people are doing with FHIR. And building on top of that national and regional personal health records, or on your phone, for instance. We've got institutions building common clinical records or setting up combined cross-institution care processes. A lot of the government reporting programs around quality healthcare and public health outcomes across the world are moving towards FHIR. Some of those it'll take 20 or 30 years to move them, but others have already moved. And from proprietary or older standards to FHIR, looking at health outcome monitoring. Most of the COVID certificates, although they're kind of not so relevant anymore, but most of the ones in the States and some other countries in the world were based on FHIR, the QR code ones. And then there's people doing clinical trial management and providing access to national provider databases. And these kind of things people are currently doing using FHIR, much more, of course. So FHIR is, at heart, a RESTful API where you have HTTP-based access to JSON or XML resources. So most people are using JSON, although when we started, most people were using XML, but we've kind of had a bit of a transition as people have slowly unwound their XML stack and focused more and more on JSON. Apps have always preferred JSON, whereas the backend systems have this comfort with XML, but it's increasingly as JSON. And we do other kinds of access to some RESTful APIs, backend messaging, bulk data transfer, exchanging frozen, effectively document snapshots of information. But for me, the security part, I'm going to focus on the RESTful API part. And then all those resources that we provide access to all of them map to some kind of healthcare record, a record of health, or of a request for something to happen in health. And most of our work is around describing the contents of those resources and how they map to real world clinical or business processes. Like I said before, healthcare is really inconsistent. And so we pay real attention to variations on the standard. People use different terminologies, SNOMED or LOINC. There's very well-known concepts in healthcare that are very unique to healthcare. And because there's so much variety, and you can't believe how much variety there is across different countries in particular, and FHIR is an international standard, we have a strong focus on reflection and metadata publication, and you can look at them and determine whether the different systems are compatible. And of course, the other thing is then having written a standard and everybody's customized the standard and republished, variations on the standard for their own systems, then people go ahead and write their own implementation. So you might have a single tightly constrained specification for a particular kind of exchange, and you have 100 different implementations of it, all trying to be, to some degree or other, as identical as they can. And so they have, hopefully they have the same functional behavior, but they're all entirely separate implementations, all with their own deployment, their own security frameworks, their own support behaviors. So that also is very inconsistent, particularly at an engineering and security level. Just very quickly, here's an old XML representation. I really dig around to updating this, but each resource has got an identity and information about when it was last updated. An actual HTML representation is built in case you don't know the resource content. You don't really have to engage with that. You just show the HTML to the user. We predate Common Mark. You might have used Common Mark, but it was too late once Common Mark didn't exist. A way to extend the resource with your own content, your own fields that we weren't standardized, and then a typical standard data set. So that's what a resource is. And then there's an API to that. It's a pretty typical API. There's nothing, as much as we could, there's nothing special to read and write and update and search for resources of a type. It could be a patient, or it could be a medication, or a prescription, or a care plan. There is some special stuff at the bottom where we get into really organized, orchestrated exchanges around, but with single HTTP exchanges. I won't go into the details. The core that's interesting from a security point of view are the first few: create, read, update, delete. And the first thing to comment about is delete. In fact, healthcare records, we're pretty resistant to delete in healthcare. Just because the record's no longer relevant doesn't mean it wasn't relevant in the past to someone's care. And so a lot of systems don't actually delete, and sometimes they pretend to delete, and sometimes they just outright refuse. We never delete information. We can mark it as no longer relevant, but we always have it there for audit integrity changes. And actually, for most systems, that's considered a security feature of the system. You cannot delete information really, or even apparently. But of course, it's obviously of security interest. You can't provide interest to someone's healthcare data, or particularly to their healthcare service provision record, without having some security on that. That's pretty straightforward and obvious. And particularly, you can even, with FHIR, you can even hook up the person's, pump that's actually filling them with medication of some kind or other to the network and control the behavior of the device, so that you can hook those devices up to your EA, your health management system directly. Obviously, it needs really, really good security. So the first really obvious thing is that security, the FHIR specification, doesn't actually make any security requirements. And because sometimes the exchange that you're interested in, the data you're exchanging, is publicly available bioscience information. There's no need to secure it. And so you don't log the user in, you don't provide the user any write access, it's just read-only access to existing published data. And so there's no concept of logging in for or security other than the inherent security of the system itself for that kind of service. On the other hand, you might be providing access to someone's personal clinical healthcare record that's making it available over the internet. Obviously, you need pretty good security on that. And because of that, the FHIR specification says, well, you should have some appropriate security, but we can't tell you what it is for your particular context of interest, how you're using it. But then we build sub-communities that share a common approach and how to secure the FHIR API. So some of these contexts, for instance, I've talked about this one already, publishing public knowledge about medicine and biology, right? No security at the user level. It's just a secure system because you don't want people to hack that system, obviously. Or you might be running a client-server system where they're all behind the VPN and you probably incorrectly assume that the VPN and the associated network security is sufficient security for your use case. It's getting harder and harder to pretend that that's actually appropriate, but there's still people doing that and investing deeply in network security. On the other hand, you might be providing healthcare records or services to a patient over the cloud, in which case security is inherently part of what you're doing in the API itself, and obviously control of healthcare services. And then people are doing this where you're a hospital at the home running a home client that actually provides services to the network, to the institution to do things to and for and on behalf of the patient. Obviously, those things have very high security requirements. And so the FHIR specification assumes that the underlying IT implementation, the web stack, is secure. Like some of the actual implementation guides that we build on top saying, okay, this is how you use FHIR for this particular context. Some of them we've actually said, well, you should probably have, like a secure web stack, the actual application part. But really, it's not our business to restate those things. We're just saying this is how you would use an API for FHIR. So you should actually secure this stuff. And so it's really obvious to us who write the specification, who think really long and hard about how to use APIs, that it shouldn't be our business to actually describe those things. We have a security group that focuses on security, and we actually have some security concerns inherent to the FHIR specification itself. And I'll get to those. But before you even get to that point, you have to assume that the API infrastructure itself is secure. And so that means that you've got to focus on the OS top 1000. There's lots of things you need to do. You've got to get that right. It's critically necessary. And to us, actually, it was pretty obvious that you would, because mostly we work with professional engineers from big healthcare providers who, grant that those things are obvious and necessary. And so we do assume that you have a competent security team that's, equipped and can respond very quickly, and that you're probably implementing the specification in layers where, the outer layers are principally concerned with security, and the inner layers are principally concerned with functionality. So we kind of make those things as assumptions, but you do actually, as an implementer of the specification, your business is to make sure that that actually is true. And there are a number of open source libraries that we provide that people do implement into their implementations, but mostly those are not associated they're not dealing with the security part of the implementation, and they're not really maintained deeply secure fashion. Although we've had some CVEs reported against some of the open source libraries, and so that part is stepping up, and so there is some work, but we assume that most of that's true. Now, I do want to stop at this point and say, does having a standard API that everybody's using, is that a good or a bad feature for from a security point of view? And it kind of cuts both ways, because everybody's using the same API. You can write a hacking tool that hacks everybody all at once. Whereas if they're all using different APIs from scratch, you'd be looking at going, well, how do we get started here? And so in a sense, having a common specification makes it easier for the attackers as well as for, the rightful implementers. But it's really interesting, because having a common API creates an ecosystem where is economic value in white hat hacking and penetration testing that tests all the same implementations. And so Alyssa Knight, for instance, is a classic case in point. I'll get to what she did, but what she did was actually not really feasible if there was no common ecosystem all using the same API. And so the penetrations that she found, which we'll get to, would have remained undetected by white hat hackers and been penetrated and used by black hat hackers instead. And so creating a standard environment creates an environment, an ecosystem where it's worth building security tooling. And the most obvious security tooling in the FHIR API space is API accelerators and security front ends. And we actually have seen a lot of those being used by the professional, healthcare organizations. Now, the only thing that we really say about security of the API itself is that we recommend the use of OAuth 2. And in fact, we went ahead and published a specific profile of OAuth 2 called Smart on FHIR. And there's a URL to the actual Smart on FHIR, the OAuth 2 profile. So the profile was based on extensive research by institutional vendors. There's some very specific features of the way we profiled OAuth 2 and OpenID to prevent some replay attacks on the standard OAuth servers. But mostly their focus was to describe how the health context is described and exchanged. I'm logging into a particular user record. How do I identify that user record consistently across healthcare contexts? And how do I describe the scopes of the kind of services that you're asking for and standardizing that for healthcare? There's a bit of more standardization around discovery and user interface integration around colors and fonts and so forth, so that you can fit into an existing healthcare record. One thing of particular concern in healthcare, for instance, is the patient banner. So it's pretty standard practice that in your actual patient-oriented healthcare record, there's every single screen displays extremely clearly who the current patient context is, so that because people in clinical hospitals and so forth, they're walking around, they walk up to a computer, entering some data, going off and talking to another patient, and coming back to the computer. And it's very important to display the current patient and a photo of the current patient as well, so you can see visually, am I dealing with the right person? That's best practice. So one of the things that we wanted to say for an app running in the context of a record system is the record system displaying the patient banner, or should you display the patient banner? So this kind of additional user interface integration that we're interested in. So it enables single applications to work across multiple EHRs. They may be visual or not. One great example is Apple phone is connecting using this OAuth 2 profile to multiple healthcare records. What we didn't do is offer any standardization around directory management and user management, client registration, application registration. Well, that's off the table for now. We just profiled the OAuth 2 authorization process, which usually implies, not always, but almost always implies an authentication step process as well. So we profiled OAuth 2. Now, the other thing that we don't do is that FHIR does not standardize access control. I mean, XACML or any of those kind of standards. So we don't actually say anything about who gets access to the data. We assume that the underlying system that's providing access to data through a FHIR API knows who the user is through the OAuth process and what they're allowed to get. And we assume that that access control is running and decisions are being made, but we don't say anything about them, and we don't describe any way to talk about them as part of the FHIR specification. We just take for granted that they exist. We describe the access routes to the data and focus on that and assume that the system will be deciding, is a client authorized to make the request, and what subset of information are they allowed to see in the response. And so that's the first, the clippable clinical system has really complicated, layered access approach to managing user access, specifying user rights. Users have access to most data. These kind of users have access to this kind of data. These very special users have access to sexually transmitted disease data. It's really, there's layers and layers and layers in a typical clinical application. And we have collectively agreed that those parts of the systems are so specialized and so specific that we're not going to try and make those parts interoperable. There's no way to describe those systems in a consistent way across the API. The effect of them is always there, but we don't have a way to consistently manage them. Maybe one day in the future we'll get consensus that we should do that, but we haven't got that kind of consensus right now. And so we just assume that there is access control and you're managing it somehow. Now, but there's some specific healthcare complexities here, because in the healthcare context, and I have never heard of this outside the healthcare context, there's a concept of break the glass. And so this is not a FHIR concept, it's a healthcare concept. You present at the hospital unconscious. And have you given the physician who's going to care for you when you're unconscious access to your data? Well, who knows? You're not there present to consent, to agree that they can have access to your data. You're there unconscious. So in that circumstance, they have this concept called break the glass, where they make a claim to the system that you're unconscious and you can't consent, and we don't know why you're unconscious, so just give me everything, and I'll accept that carries a number of legal consequences for making that claim. And typically it gets special audit entries in the audit trail and get specific review whether that was used appropriately. But a practicing clinician, typically has the right to ask for all security to be set aside and to have full access to whatever. And so that's allowed. You can't exactly turn up to a bank unconscious and, they do the same thing. I guess for me, that's only a healthcare concept. So one of the other things that we assume that there's a lot of legacy access control that it already exists. And if you're writing a new system, then you'll have to reproduce that. And honestly, if you're a healthcare system provider, most of your focus on security is actually going to be at the access control. There's a serious amount of work here, and there's a serious amount of risk that and you're just trading here. This is a real nightmare, because you're trying to provide access to the data people need. And so people will come forward with special cases. I need this data. But the more complicated the layers get and the more routes there are through your security control mechanism, the more difficult it is for the administrators to figure out what they've actually done and who's allowed access to what. And so they really want simplicity. It's a whole difficult subject. And so most of the security work that you do in healthcare is actually around getting access control right, but it's not enough. Now, a key part of the system defense is the audit trail. And in healthcare, a key part of who you're defending the system against is insiders. And in fact, in my experience in healthcare, the single most common attack on the healthcare system, other than hackers from outside, script kiddies just banging away on the API, hoping that the parts that you actually worry about that I've seen end up in court cases or whatever, is the actual system administrator attacking the system. And so you've got to have an audit trail that's proof against the system administrator, and that rarely is. So you should have a very, very thorough audit trail. It should be generating gigabytes of data a day. It should be very comprehensive and record as much as it can, and it should have really good analytical tools. In fact, this is so important in healthcare that FHIR actually makes this part interoperable. So you can actually delegate the storage and management of the audit trail to a separate system. And you can, by doing that, you can actually say that the subsystem that does auditing is running as an independent system from the core system, and you can make it resistant to tampering from the system administrator themselves. So, and that's a great use of blockchain in the healthcare. And in fact, that's one I've actually seen in practice, although I'm hoping to see a market mature around audit trail management. And a good system will have a professional team whose sole job in life is to review the audit trail, so that the staff, because typically staff have awesome access to the clinical record in case they need it, and they have to refrain from inappropriate usages around, VIPs and other staff getting care. And a key part of the resistance of the system to that kind of insider mismanagement is managing and inspecting and auditing the audit trail. And then the users know that this happens. And I've had major administrators of major hospital systems tell me that they dismiss one staff member a week on average for things they found in the audit trail. It happens. Now, another thing we do specifically about security in FHIR is that any resource or request can be labeled with one or more security labels. They're little tags that you're attached to either the HTTP request or more commonly to the resource, and they're basically flags that are fed into the access control engines to control to inform the access control engines about how to make special decisions relevant to this. So we have hundreds of security labels that you can tack on resources, but some common ones is to label a record as a VIP record or a staff record. This is a staff. Like, staff will get treatment in the same institution. You really want to know that it's a staff record, and bells ring when someone accesses another staff member's record. Of course, obviously, at times that's totally appropriate, but also it's obviously times that's totally not. And the access control engine might do specific decision. For instance, it's a typical thing to track specifically that a person is working in the staff clinic and has access to staff records, and everybody else doesn't. And so those kind of records are labeled as staff records. Some records specifically labeled as confidential. Some of it, a lot of them, mostly they're implicitly confidential, where, if you're seeing a psychologist, your records are implicitly confidential, and that's pretty standard in the healthcare system. Whereas you might, for instance, make a very, very private disclosure in an emergency department because you really have no choice, The physician might look at that and say, most of the stuff that happens in emergency is totally not very secret. A lot of the stuff in emergency is straightforward. You get hit by a car, there's nothing secret about what comes with that. But sometimes you have to make a very confidential disclosure in emergency, and so they can actually tag that specific disclosure and say that one's really confidential. Another thing you might tag is the kind of purposes of use that the information's approved for. You can actually provide use restrictions saying, I'm giving you this resource, but this resource is not suitable for you to store or do anything else with other than look at. Obviously, it's up to the receiver of that record to decide whether they're going to honor the request, but the label represents the request to do that. You can mark test records, and John, who's speaking after me, has actually just made a blog about this today, about how to use that mark test records in live healthcare systems. And I've never seen a live healthcare system in a large institution that doesn't have test data, test records to the patients. In Australia, where I live, it's traditional for the test patient to be called Donald Duck. It's actually some actual Donald Ducks in Australia is actually their name. And so that's created some problems. So you actually need to specifically mark them as a test record. And of course, there's labels for break the glass. Now, in terms of digital signatures are pretty well understood technology, but as far as we can tell, using digital signatures with RESTful APIs is very much a research project. I mean, of course, we use them at the transport level at TLS, but how much, we're in a very dynamic system, where do signatures fit in? We've looked at hashes, but how much do you want to secure over the transport layer? And one of the big challenges here is a lot of data exchange in healthcare is characterized by fiddling in the middle, and we call these interface engines, and they sit over the transport layer and manipulate the information as it goes by. And there's a whole vendor ecosystem and product space around interface engines, where we're trying to manage information complexity and mismatched business processes and mismatched systems. Obviously, if you've got systems in the middle fiddling the data, you can't have signatures. And so we can't imagine not having signatures, and we can't imagine not having interface engines, and we can't imagine how we're going to resolve that. And so this is all still basically research stuff on the API and quite contentious. But it does mean that in practice, digital signatures are confined to secondary copies of sets of data that, are not pertinent to the current healthcare processes, but we can at least sign those and store them in repositories and share them, and then clinicians basically ignore them because they're historical information, who knows? So it's a whole open question for us as to how much we can secure the information in the live system. It's a very difficult problem. There's actually some very specific FHIR issues around binary attachments and narrative. So a lot of the exchanges in healthcare involve scans of paper documents, faxing information around. I read somewhere that 95% of the fax machines sold today are sold into the healthcare system because we fax everything. So, and then increasingly that's, back-end fax services generating TIFF documents or PDFs, emailed documents, Word documents, I love Word documents, and images and ECG data files and so forth. So these appear all over the place in FHIR users at context of use. And each of those binary types introduces security issues of their own. Do you install PDF fonts when you look at a PDF document on your highly secure, sandboxed clinical desktop in a hospital ward or a doctor's office? Do you install the PDF fonts? Well, that's a whole problem of its own. And then there's a whole set of parser and renderer exploits. We know all about them. And very often you're running those in actually a privileged context where you've got access to patient records. So people have very different approaches to how they handle that in the healthcare, but you can't ignore that issue. And when you've got an attachment, you got to worry about this stuff. What do you do about word macros, embedded HTML objects? Yeah, when most of us ban those, just can't have them, period. John's going to talk more about some of these issues, I'm sure. Another one that's really difficult is I send you a HTML document. It's all standalone, but there's one reference to a 1 pixel image in the document, just so I can know who's reading it and where. Is that good? Is that okay? Is that secure? But even if it's okay, you have to really worry as the host of rendering that content as to whether you're leaking headers. You got no leaking headers. And if you're not doing any of those things, are you rendering the content faithfully and clinically safely? For instance, it's just clinicians do this all the time. I highlighted the content that really matters in red. They're like, well, the red fell out because of security issues in the infrastructure. We weren't going to render that layer of influence over the content, and now we don't know what the red content is, and we don't know what he thought was really significant. That's a real world situation. And of course, and then you've got to add access control and record synchronization in on top of all that. And so that's just an ongoing challenge for everybody. And of course, we have narrative in the resources as HTML. That's got all those issues. And for that reason, there's actually a general FHIR validator that's specific to FHIR and mostly validates the content. Is it correct? Not in a security sense, but has a security mode, so it can look for embedded SQL attempt and references to external content. Got options for those things. And then at the last level of consent, assuming that the system exists, is stable, the APIs are solid, all the record and the information management is good, access controls in place. Finally, there's the concept of consent. And to record an agreement made between a patient or their agent and a record manager, an institution, a person, a doctor, about who can see their healthcare records and why. And these typical things people are sensitive about is their actual demographics, their base demographics, who they are. They're worried about next of kin finding out about abusive relationships. That's something we're very sensitive to in most contexts in healthcare. They're very sensitive about information about STDs, substance abuse, mental health. And also people are increasingly sensitive about genetic sequencing and risk assessments associated with genetic sequences. The problem with that one is you simply can't repudiate that. If some hacker gets your your address and even your name, you can change that, but you can't change your genes and you can't change your medical history. And so some of these need to be handled really carefully and need to be really careful control over who's allowed to see it and what. Now, healthcare records are generally exempt from consumer access rules such as GDPR and Europe. Health institutions that keep records for health purposes simply aren't subject to GDPR in regard to the health records. They might be subject to GDPR and other examples. But then typically in most countries, there's specific legislation that controls management and access to healthcare records. The states as HIPAA, and very often that includes regulatory control over consent. And then there's consent not just about what information to share, but what treatment to provide, and around do not resuscitate and advanced care directives for patients as they age. And then this, for us, this is a key part of security, and it's nothing to do with the API. It's a much higher level than that. But it's important at the API level. When you make a request, do you have not only access, but has the patient consented to share that data with you? Well, the other problem with the healthcare system, which drives me nuts, you rock up in an emergency department, you have a physical emergency, and the hospital says you need to consent to share for us to manage your information. That's not really consent, but they still call it consent. Okay, so the current state of security for us is that the EHR providers, the health records, the serious institutional vendors invested deeply in security. And as far as I know, there has been no penetration of their systems. And they care about that greatly. They have security teams. They could be good. They can talk to this. They should be the ones giving this talk. But other participants in the health ecosystem, the ones that use the APIs to get the data and then republish them over APIs, they were caught with their pants down by Alyssa in a report she did a couple of years ago. I mean, honestly, pants down. It was embarrassing. The stuff Alyssa found, what are you guys doing? It's healthcare information matters. You mightn't have, you mightn't be the primary healthcare provider, but it matters. And it was embarrassing. And it was weird too, because the thing about FHIR is there's implementations everywhere. And at the same time, I was on a phone call with Alyssa when she was publishing a report describing how she caught these participants. It was kindergarten level stuff. I really don't know what to say. And I'm like, when I publicized her report in the FHIR community, I'm like, guys, it's just embarrassing. But I got off the phone call with Alyssa and onto a different phone call with a bunch of engineers trying to figure out how to secure the validation data of the resources that were the FHIR exchanges running on a national program, national backbone, how to secure those using SGX against the health, the cloud provider not being able to see the data. It was just this like weird whiplash thing, because on the one hand, I'm talking about providers who didn't really have security at all. On the other hand, I'm like far end of the deepest security. And so implementations really in healthcare are all over the place. But the thing is, health data really matters. Health, and you can't change your health history. Although patients are an innately hard target, like other than simply stealing someone's identity, which is common grounds for attack on healthcare data, because healthcare really keeps good identity information. Once you get someone's health history, they're innately hard to target about that. The patients are hard to target. I find it did happen. It happened here in Australia. Somebody hacked a API of a health insurer and got a real great deal of internal information from a health insurer, and then they started actually prowling that data. It was all billing data, but it had billing codes in it, so you could see what patients were billed for, and so you could infer what patients had mental health issues or STDs or so forth. Looking after the patients, it's really, really hard to go after individual patients. Maybe the patient didn't care. Everybody in the family knows, his employer knows. What more is there to say? And so it's just like, well, you can't really do anything with that. But what you can do is go after institutions, and that's what happened. The data was weaponized against the institution to force the institution to pay up. There's a blackmailing, and institutions are an easy target. So that's really that in current practice, the institutions are the target of the attack, not the patients. And the institutions are the ones who have the data. And the phrase that we're increasingly using in healthcare, I'm hearing it everywhere, is that data is a toxic asset. It can blow up on you at any time because you didn't manage it really, really carefully. And that typically means the hackers go after the institutions. I don't want to say one thing about this, which is that I have had a report from a NATO commander that Russians are actually going after individuals. Russians are penetrating data, getting patient records, and then going after specific high-value individuals in Europe. So that is certainly something that does happen. Obviously, I didn't get any more details than I was never going to, but that is a concern in Europe, and increasingly, I would think it's going to become a concern in USA as well, where the security of patient data is going to be a national security issue. So, overview of security. John, I'm sure John will cover this better than I did, but obviously your API infrastructure should be secure. Layers of security, please. Timekeeping matters for security, for audit trails and clocks and signatures. Communications and authorization and authentication you should have. Good audits, good provenance tracking, careful with attachments and narratives, and manage your data really well. Serious investment needed here, and you cannot afford to get this wrong. But I'll just finish at this point. Say FHIR is an idea about building an open source community with knowledge that everybody can build on. Because it's public treasure that everybody owns, and everybody's richer because everybody owns it, and we can all assume everybody has access to it. An open community is the best way to develop common infrastructure, and FHIR is part of a web of open communities. We have other specialized FHIR communities, and we have relationships with other open communities, clinical and technical and bioscience communities. And I encourage all of you to spend some of your time contributing to civil society by being involved in some open community. It doesn't have to be FHIR. We've got plenty of participants that build common public knowledge, or create your own. But I encourage everybody to do that, because it's actually something we can do to defend civil society from the current assault upon it. Thank you for listening. And that's it from me.
Thank you so much, Graham. That was a fantastic, fantastic presentation. I feel like FHIR has been a household name in my house, at least in 2021.
Sure,
Unless it's been a year of that research, and all I heard was FHIR this, FHIR that. So playing with FHIR was definitely one of her, I want to say, her longest research projects, and she super appreciated working closely with you, Graham, and John, after getting connected with HL7 and just working in that community to help kind of give some really good recommendations. And with still, hopefully it's been a couple of years, so hopefully it's been getting better. And of course, like you said, it was remedial, it was like, kindergarten type attacks, and something that was super easy for pretty much any, beginner to do. So obviously the takeaway from that was, implement zero trust architecture. She calls it the woman in the middle protections, hack your own APIs, right? Test them. And I think I really want you to elaborate a little bit more that in the research, what was, very evident was that FHIR was not the issue. It was the third-party aggregators that were the main issue. And I know there's been, I want to say, John, and John has been very active, Graham, in this chat. I think out of all of my purple tracks today, Graham, this has been the most lively chat dealing with healthcare. So we'll get onto some of those comments in a minute, but I really want to, for those who haven't read the paper yet and have not been familiar with FHIR, really to talk about some of the use cases that were identified in the paper regarding those third-party aggregators.
Yeah, and I think the third-party aggregators, I mean, honestly, it was embarrassing. You guys, data matters, and people are trusting you with this data. Mostly they aggregated it from the patient rather than from the institution directly, although it was a big wake up for the institutions to be more careful about who they share the data with. But they got it from the patient and it just didn't care about it. It's like, it's just embarrassing. And really, it's a part of, I mean, there are parts of healthcare that it's taken healthcare a long time to get on board with the security agenda. And I remember working in an institution, a hospital, where the keyboard, on the numeric keyboard, 9 and 6 and 3 and dot would wear out quicker than all the other keyboards, because the doctors had realized you could have your secure password was 963 dash. You just run your finger down the numeric keypad to log in. They loved it. Security, healthcare people often don't pay attention to security, but increasingly that's in the past. Everybody's on board with it now. We know that we really don't have any choice. And I thought that was the same attitude that underlaid, the things Alyssa found on the data aggregators. So we're just like, we don't care. And it's like, well, you better care. And really at the end of the day, it was, did they care or not? Because if they cared, they could have done what they needed to do. And yeah, so when Alyssa contacted me at first, I was really worried that she'd found something wrong with FHIR, and then she showed me what she'd found. I'm like, we worry about FHIR and getting it right. There's some of the stuff I talked about. It's like it was never even in play. That stuff. It was just like secure your API.
Exactly, and I think to me the biggest. I mean, I was dumbfounded when she was explaining to me what she found and how she told me, she's like, hey, Mel, she's like, you and I can, with no experience, spin up a startup and be a third-party aggregator. And, why have to spend all this time researching and doing recon against the healthcare entity where you can just go to the third party and get all the data right behind the keys. You can pretty much get anything you want, and it takes a third of the time. So that to me was the biggest gotcha. And so I was really not excited. I was like, oh, this is going to be difficult, because I feel like healthcare is always the last vertical to catch up, and I think it should be the first, right? Because we're dealing with patient data, we're dealing with all these different types of vulnerabilities. And I think John actually made a comment that hospital devices don't use FHIR. They use a standard from HL7, right? Before FHIR. So I think that
And in fact,
so I
the
think
problem is that we did all of a lot of our early integration work. We did it in the 70s and the 80s, and now we're just paying the price for being first.
Wow. So I think we're getting to a better place today with all this awareness. What are some other challenges that we're seeing today in, I think, the healthcare industry? We're seeing a lot of individuals and experts try to go and protect APIs and really understand the architecture behind it. What are some other challenges that we can bring to light that are easy to fix, quick wins, so to speak?
Well, the most obvious challenge for me is not an easy one, which is that health security problems in your APIs are political issues. That was that caught me by surprise, was how political Alyssa's report became immediately. It was immediately discussed on the Hill in Washington. Any security problems in healthcare APIs here in Australia are political problems. And so, one of the big problems for us is there's twin guidance coming out from the government. One, we want everything in the cloud. We want to be able to have the information and make it available so that people can have what they need when they need. And so that's one thing they're saying. And the other thing they're saying is they're freaked out about the Chinese attacking Australian infrastructure, and that's a very real concern. And can we not move anything into the cloud at all, please? And of course, right, at this, at the technical level, everything's in the cloud now, whether you think it is or not, given, what's happened with infrastructure. And so actually for me, that's one of the primary problems that we have. Looking more at the technical level, all of the hacks that I've seen in the real world so far have been, like the one here with the Australian insurer getting penetrated. They put up a development API in their in-house development system so they could get access to their data, so that people doing the data work could just get the data that they needed. And then they accidentally put the development API live.
Whoops. Oh my goodness.
Whoops, no security on access to the internal data, that they had. Obviously a very, very big oops. And most of these things, that's what they are. They're, someone put in a hard-coded password in a dev system, and then that crept out into, that's happened heaps and heaps of times, not just in health, and it crept out into public. And so, I keep coming back when I talk to the FHIR community on this stuff. It's just like, it's a cultural problem of discipline and defending your system. Do you choose to have build systems that check there's basic security checks? Developers, this is what we're good at. We're always hacking around stuff all the time. And so it's really for each developer having a security culture with them. And so, like, one common thing that I've seen at large healthcare institutions and vendors is that everybody who works for them has 2 laptops, right? And you give 2 people 2 laptops. One of them is locked down and gives access to the production systems, and you can't use it for anything else. And the other is your dev machine. You do whatever you want with it because it's got no access to anything that matters. And you give people 2 machines. That's an enduring investment in their thinking about security culture. And so it's not unusual for people who come to HL7 meetings and FHIR meetings to actually, the ones who work for production, IT system vendors or who work for institutions, to have 2 laptops, one in case they have to actually do something with production systems. And for me, that's a really cheap way to invest in security. And so if your institution is not doing that, you should ask them why. Don't you care? Give me a second laptop.
No, for sure. And to your point, I think there's a lot of, very intelligent individuals in the field. And I think it's more of a people and process side where you have to force them to think differently, right? Because everyone is doing their job day in and day out, but not really thinking about or forward think, right? Against the vulnerabilities and the threats that are out there, right? So I think that if you set those processes and that governance in place, and I think that's what HL7 is doing now, I think that will definitely help with the security posture, or at least advancing it, right? I think at this point we have to make the developers and decision makers accountable and ensure that they have the correct API implementations and are secure with process, with governance.
HL7's business is not in a position to say you will do this to, our members. It's really, that's the business of governments and other or regulatory agencies. But we are developing some tooling for them to make it easier for them to do so. But it's, in the end, it's up to the institutions to decide whether they care or not.
You can only say like, hey, we recommend doing this. This is best practice, but it's up to them. And I think to your point, it's very political, right? Because unless there's some type of law that's created that says if you don't do this, we're going to fine you, kind of very similar to PCI compliance, right? If certain compliances are met, they get fined, and that's why there's such a big rush to make sure that they're that they're compliant, and they have all those quarterly audits. I think if they think in that same way, I think we would be a lot safer. Another thing that I remember Alyssa's telling me is that it's a good investment to look at an API threat management tool that allows for observability, because even still, with all these precautions in place, we still need to monitor and enhance those capabilities for any future threats. So continuing, because as we're in an IoT world, APIs are 80% of the internet. So there's always going to be evolving threats in the future.
Certainly is. I'm really looking forward to the standard security penetration testing suites starting to get specifically involved with FHIR and exploring some of the higher level issues that are FHIR specific, but still very real issues around the kind of things that I talked about. They haven't done that yet, but I'm pretty sure that'll happen soon.
I can't wait, and that's going to be great news, and I'm sure Alyssa's going to love to hear that as well. Well, Graham, I want to thank you so much for attending our conference here on the Purple Track. It was a pleasure having you. And any final thoughts before I let you go?
No, I mean, the only final thought that's pretty obvious: security matters, so be careful.
Okay. Awesome. Thanks so much, Graham. I appreciate you.
All right, thanks. Bye.